Okay, here we have a question that's straight out of a final exam. This is one of those Part C questions where you have to show your work and you can get part marks even if you don't get the question right. So this question, I'll read it to you and then I'll explain to you what we're looking at before I start. The question says, it's called the street light. It says Tom's street is on an incline. You can see they've drawn a picture here of the street on the incline and then they've redrawn it as just sort of geometric shapes down here. It says Tom would like to know the height of the street light on the front of his property. Here's the street light in the real picture. Here's the line that represents the street light in that drawing. It says from the street light, Tom walks up his street for a distance of 4 meters from here to here. From where he stops, the measure of the angle formed by the street and his line of vision relative to the top of the street light is 75 degrees. That's pretty confusing as far as words go, but all you need to know is that they've written this 75 degrees in the corner of this triangle right here. So it says the diagram below shows a front view of Tom's property, the street, and the street light. Various measurements are shown in this diagram. In this diagram, line BE represents the street, that's from there to there. Right angle BAC represents the front of the property, so his property, his house sits on this level ground here, and this whole thing represents the front of his property. And line segment CD represents the street light, that would be this line right here. And they want to know to the nearest tenth of a meter, what is the height of the street light? So now let me figure out what I'm looking at here. Well, the final exam questions for Part C are always set up the same way. You get the question on this side of your booklet, and this side of the booklet is reserved for showing your work and writing your final answer down here. Now down here in this corner, this is where your teacher is going to grade this question. You can see that a perfect score in each question would be out of 100. You get marks. These are criteria. Criteria 3, criteria 2, criteria 4, and 5. Criteria 1 is saved for different types of questions. Now, it's not important for you to know what the actual criteria are, but it is important for you to know that what we're looking for on these questions and what they want you to show for us to grade it properly is that you understood the question, that you know how to use the proper procedures, that's just a series of steps to obtain an answer, and that you support your work the whole way through. Also important is actually writing your answer on this line down here. So let's try and figure out what they're asking for in this question. Now here, it's a trigonometry question. I think we can all see that. I know that I'm not going to use any of my area formulas because they're not asking me for the area of any triangles. So the first thing that I'm going to remind myself is that I'm either going to be using SOHCAHTOA or sine law, maybe both. And it's possible that Pythagoras could help me here because I have this right angle triangle. The second thing, those are all the formulas I'm going to choose from when I'm doing my work. The second thing I want to remind myself is my 180 degree rules when I'm dealing with triangles and trigonometry. One of those 180 degree rules says that any angles that form a straight line add up to 180 degrees. We can never forget that. That comes in pretty handy, especially on these Part C questions. So any angles that are back to back, now I've drawn 2, it's possible you could have 3 or 4 or any number of angles that make a straight line. They would all add up to 180 degrees. The next 180 degree rule is that if I have a triangle with vertices A, B, and C, the angles formed at A, B, and C also all add up to 180 degrees. The sum of the interior angles of any triangle add up to 180. So that's also important for me to remember. Now I'm going to get started with my work. I can see I have 2 triangles here. I've got triangle ABC formed right here. That's a right angle triangle. And then I've got triangle CDE over here. This is not a right angle triangle. Notice this 90 doesn't form 180 because this line isn't flat with this one. But there is a case of supplementary angles there. We'll get to that in just a second. So I know I'm going to be starting over here in this triangle, and there's a couple of things I could find. I could either find the hypotenuse, line BC here, but I'm not really sure how that would help me. The other thing I could do is figure out the missing angles, and specifically this angle right here I think is going to help me, because what I can see, and it's really important that you spend time looking at this until this jumps out at you. What I can see is because the street is straight, even though that's on an incline, the 3 angles that are back to back to back to form that street would all add up to 180 degrees. Now I know this one's 90 degrees, And if I found this one using SOHCAHTOA in this triangle, I could subtract those two from 180 to find the missing one. Then I'd have more information to work in this triangle here. Let's try that. So if my first two steps were just reminders to myself, the third step is where I get into some actual mathematics. So I'm going to redraw that right angle triangle. That was triangle ABC from over here. And I'm going to fill in the information that I was given. This is 2.8 and this side is 20. And what I was looking for, this angle here, would be that right there. So between SOHCAH and TOA, so I can decide which one to use, I'm going to label the triangle. This would be the hypotenuse because it's across from the 90-degree angle. Across from the angle I'm working with is my opposite side, and the third side we just call ADJ for adjacent. Now what am I going to work with to find this angle? Here's the angle that I'm looking for. I have the opposite side and adjacent. So out of SOHCAH and TOA, the one that works with opposite and adjacent is TOA. So I'm going to write out that the tan of that unknown angle is equal to opposite divided by adjacent. That's 2.8 divided by 20. Now to solve for the question mark, I'm going to create equivalent fractions so I can see easily that my cross product would look like this. 1 times 2.8 divided by 20 gives me 0.14, but that's the tan of the unknown angle. To get rid of the tan in front of the question mark, I've got to do shift tan on my calculator to get that tan minus 1. And when I press equals, I get, and I'm not ready to round yet because that's not my final answer. So I'm going to leave 4 decimal places to be safe. This is good practice in any of these questions. At the end of it, you're going to have to round to some number that they're asking for. Along the way, keeping 4 decimal places is safe. So now my fourth step is going to be to try to figure out what this angle right here is. And this, I just found, that angle is the 7.9696 degrees. And if I call this angle X, let's make that a little bigger. If I call that angle X, then that angle is going to be 180 degrees, because remember these 3 form a straight line. That means they all add up to 180. Notice that makes a half circle there. So 180 minus 90 minus 7.9696 is going to give me this angle X right here. So 180 minus 90 minus 7.9696 leaves me with 82.0304. Again, I'm not ready to round, so I'm going to leave all those decimal places in that number. Now here in my next step, I'm going to draw out this triangle that I'm going to work with, because I'm ready to just focus on that one right now. So what do I know about this triangle? Well, this side length is 4 meters. This angle I just found, it's 82.0304 degrees. This angle is given in the question, 75 degrees. And this angle I can find. And again, I'm going to subtract these 2 angles from 180, because remember, the 3 angles inside a triangle add up to 180. So I'm going to do 180, let me work down here, 180 minus 75 minus 82.0304, and that'll give me this top angle here. So 180 minus 75 minus 82.0304, that gives 22.9696 degrees. So that means this angle up here, 22.9696 degrees. Now I've got enough information to work with sine law here, and remember, they were looking for the height of the street light. That would be this side right here. So I'm going to label the triangle for sine law. So let me label this triangle for sine law, and remember, that gets called A, B, and C in any order. But once you label the angles, the sides across from those angles have to get the same letter but in lowercase. So that would be side A. Down here would be side B, and over here would be side C. That's the one I'm looking for. So I'll write out the sine law. A over sin A equals B over sin B equals C over sin C. And I'll fill in the numbers that I know. I don't have a value for little a, so I'll leave it the way it is. And it's not the side I'm looking for either. But I do have a value for big A. That would be the sin of 82.0304. That's equal to b over sin b. Now remember, lowercase b is 4. We were given a value for that. Over the sin of 22.9696. And that equals little c, which is what I'm looking for, over the sin of 75 degrees. That was given in the question. Now I can see I don't need the fraction with the a's in it. I can focus on this right over here. To solve for little c, all I have to do is cross multiply. Don't forget the sign in front of these two angles. I have to put that in the calculator. So this is going to be 4. Remember, to cross multiply, I multiply the diagonal values and divide by the other one. So I'm going to do 4 times sin 75 divided by the sign of 22.9696. So there's sin 22.9696. And when I press equals, my answer there, 9.90077. And they were asking me to the nearest tenth of a meter. So here's my tenths place. And to round to that, I need to look one spot to the right. Since that's below 5, I don't touch that number. So my answer, 9.9 meters. And I have to make sure that I'm going to transfer that down to that answer line. So to the nearest tenth of a meter, the height of the street light is 9.9 meters. And that's my final answer. And that's showing enough work and numbered steps so that when the teacher looks at this to correct it, they can come here and write 100 on that question.